Yo yo yo! Today we are going to code a machine learning based AI system for the Omnitrix. Let's start by creating a folder. I will create a folder named Omnitrix AI here. Okay, let's create this. Then I will copy my CSV file there. I have made the CSV file where I simulated 500 battle scenarios based on the environment and the enemy number of enemies, the threat level of the enemy. So let's cut this here, and now I will open this folder in on VS Code. You must be thinking that why I'm doing this on VS Code and not Jupyter. The answer is that I don't usually use Jupyter for even for ML models. I am more in touch with VS Code than I'm with Jupyter. So let's open this. Of course, I will do. I am the author. So let's create a py file here. Here I'm creating this py file, and let's name it something like Omnitrix AI. Of course, it's an ML model, but still I'm using AI just for the project to look a little bit cooler. Okay, now let's import the necessary modules here, pandas. Then we might install like matplotlib, but I won't use matplotlib as we won't visualize data here. So let's import scikitlearn pre-processing. We will install label encoder. So as we have to of course encode the different columns, as machine learning models don't take inputs in words, we have to convert them into numericals. Then we will install train test split, so we can split the data types, the whole data into training and testing models. Then of course decision tree classifier, that's the main thing that we are using to to predict the alien for the scenario. Okay, and what else? Accuracy meter I have to install, I have to import here. Let's import that accuracy score, and I think that's it. Okay, and so let's first load a CSV file in this CSV path. I will copy its path. Here is the copy path and paste that here. Sure, just I will paste it. Okay, and now I will use pandas to read the path and save it in a data frame variable. So let's create df equals read CSV. Okay, read CSV function we are using to store the CSV data in df variable. So we have saved it, and let's start by I using you creating a variable features to store the columns like environment, enemy type, enemy threat, and number of enemies, so we can easily access the CSV columns from this list. So let's create this here. Okay, let's go. By the way, these are the exact names of the CSV columns I used. So here comes the chances to win. The chances to win column is the CSV data that I used. If the chances are high of winning, then it gives based on the other parameters, and if the chances are low, so the alien that is predicted is usually used to run away from the situation. So here we have the target variable, which is the best alien. We'll save the predicted best alien here, and here we initialize the initialize the empty dictionary label encoders, and now we will use a for loop. We will first create a data frame using pandas, then we will use a for loop to encode all the columns as Machine learning models cannot do it in normal string type data. We have to encode them. So let's do it for columns and feature. We will see if the column here is an object. If it's an object, we will encode it. If data frame column equals to an object, then we'll check the d type actually. The data type d type equals an object, then we will encode this using, of course, scikit-learn pre-processing encoder. So let's first make this label encoder, and then we will start encoding. We will create an x column equals fit transform fit. We will just encode it fast enough. Label encoders, and now we will write just an else statement, so we can also encode the non-object type things like number of enemies in the CSV file. So let's just do it. Columns equals data frame columns, and we will transform them. Now let's just come out of the loop and write our next code by we have to oh wait, I haven't transformed. So let's start. Now this target LE variable is now encoded, so the machine learning model can actually process that. Actually it gives in a numerical format and not texts. But later scikit-learn automatically converts the encoded value into the 10 aliens we have. So let's just use the target to fit transform and the columns. The fit is used to train the model, by the way. They are also seeing the target. Like the target is the alien that in the battle scenarios we choose. Now we will split the data for training and testing. Usually I do with 80% training and 20% testing. This usually gives a very good accuracy. In my experience, I have already imported train test plate. Now I will create the variables of x train, y train, y train, y test, x test, and y test. It usually takes me a little time you to type this. You type these columns because my keyboard is very faulty. I have to use this on-screen keyboard here. So let's change the test plate and give the xy of the original data set as a parameter. We will use the test size of 0.2. It will automatically get the training size of 0.8, which is 80%, and a rand test size equals 0. Oh no, not plus, equals zero point 0.2. And random size I will give off let's go for random state of 42. Those who know. Okay, now the data has been splitted, and now we will use scikit-learn classify. Now we will first define the classifier decision tree, and then we will use fit function to train it. Let's save it in CLF, the object of decision tree. Let's just initialize the object and also a random state of 42 here. So let's go and train the model. You will use just fit and give the training data and the X train and the Y train. So let's go, just giving the X train and Y train. Later in the video we will also use the accuracies and the metrics of scikit-learn to predict the accuracy, as many times the oh shit, we were in the loop. Never mind, we were in the loop. Let's come out of the loop. can't can't realize that I was doing such a big blunder here. Let's move forward anyways. We keep moving forward. Now we will use the accuracy score so the model doesn't overfits. If it overfits, sometimes models memorize the data, and it's called overfitting, by the way. The models memorize the data, and on similar types of data they give accuracy of 100%, but on a new data they get cooked, very highly cooked. So let's print the training accuracy using metric module of scikit-learn. We will also print the testing accuracy. This compares the X training to the predicted. We will like X Y training to the predicted value that the classifier predicts of X trained. In the Y test, we compare the Y tested to the predicted of X testing dataset. This gives us the testing accuracy. Now, also I forgot to tell you, I uninstalled pandas and scikit-learn, so I will show you how to install them in the tutorial itself. I will write a comment here. Let's just write a comment here. Okay, let's go. We will run and debug the model now. Let's install pandas using the terminal pip install command. Necessary modules: pandas, sklearn, matplotlib. Let's go to Python. Of course, Python 3. Let's go. We will exit this and use pip. You can see my version is the latest one. Exit function, and we will use pip install pandas. It's installing. Let's wait for a little bit until it gets installed. Never mind, I don't have enough space to download even pandas. I just recently downloaded Linux and my hard disk is partitioned very hard. I can't download in my main disk. Actually, my PC is quite weak. Can't even run Free Fire on it. Let's just write a comment even for that. My laptop cannot run Free Fire, but still, it's decent enough. I will run the code in the next video in a Jupyter notebook. I can't install for now the necessary modules required. Still a win-win situation, at least it can't run Free Fire. Free Fire is played by idiots anyways. Let's move forward. Let's move forward and make the user input a new battle scenario so the model can predict it. As the major things, training the model and like CSV loading and encoding all the columns are done in the program. So let's just take user input for environment, threat, enemy enemy level, number of enemies. My keyboard is faulty. I cannot even print down the statements. So let's just manually type them. User input in the environment column. I will take the input. Here I will just give a string of environment. Then another user input of like of let's go for hmm, let's go for enemy threat, enemy level, enemy type, and I will double quote it and get another input from the user of the enemy type. Let's just input double quotes and enemy type. Faulty keyboard problem is very big. It slows my code a lot. Let's get another input of the enemy threat level and double quote it, of course, and input, get an input of the enemy threat level. All of this we have to encode all of them also. Then only we can then only we can use the model to predict. We'll use a simple for loop to encode them as well, like we did for the columns of the CSV. Let's go. Here we have chances to win. We will take input from the user. Let's go. Just input double quotes. Double quote chances to win. Finally, we have taken all the inputs we required. Have one four of the chances. And the number of enemies, we will take an integer input. Integer input, we don't have to encode this. No, we actually have to encode even this. So let's go. Now we will just initialize a new encoder to encode the inputs given by the user so we can actually process them into machine learning model. So let's move forward and use the loop, a simple for loop. I will check for objects. Never mind, I'm out of the loop. Wow. Yes, now I'm in. Just let's check the columns in the future. Are they objects or not? Let's move ahead. Let's keep moving forward. We have encoded the input. Input by columns, the loops will automatically encode all of them one by one. So let's move forward. See, where is the okay, we haven't used the same variable name, that's good. Nice. Major stuff we have done already. Even the encoding is done now. Now we will come out of the loop. Fit transform on the 0th index. No, we don't have to fit here. Just our transform, because fitting we are not predicting it. Of course, we will predict it later. If we use fit transform here, it will train the date. It will train the model on this data, which will lead to a high level overfitting, and the model will just memorize the data. It will give an accuracy of 100%, but won't it won't do good on new data. Let's write a else statement. to encode the other inputs like the of course number of enemies, the columns. Finally, we have done most of the things that we had to do in the project. Let's just encode the user input of 0th index here. Finally, we move out of the loop. Now we create a new X, which a new data frame using pandas to have the to contain the encoded inputs given by the user. Then we will have a new variable, let's say pred, to keep the predict. Use the CLF object to predict the alien, and now we will just inverse transform them as this is now encoded. We don't want encoded numericals. No one can understand it. We will inverse transform the it into predicted alien. Target any variable which had the y values. Now we will inverse transform, so it will go into one of the 10 values like diamond head, wild mud, etc. Just inverse transform this, and of course the pred variable here in brackets I will give the pred variable inverse transformed on the 0th index. Let's go. Now we will just print the predicted alien here. Let's print the predicted best alien for the scenario is, we'll just give the predicted alien here. Nice, our program is completed. I will run this in a Jupyter notebook in the next video. My laptop isn't strong, of course. I just gave it here. I will upload this code on GitHub, ZaidCipher. Follow there. If you guys want, we can also do a live debugging session if there are any bugs in the code. But first I will run this in a Jupyter notebook. Don't forget to drop a like and a comment. I don't mind about subscriptions. Just follow ZaidCipher and not my YouTube channel. ZaidCipher on GitHub, of course.